All right. What I want to do is show you guys how to evaluate, how to do this problem by using it as a by using period as an aid. So previously, what I've showed you guys to do is, if you want to evaluate this, you first need to find where is this coordinate point on a unit circle, right? And the theory that I told you to use was, if you make a unit circle, you can break it up into whatever your denominator is. So since my denominator is 4, I'm going to break it up into 4s. So this is pi over 4. Actually, you know what? We're going to use the negative direction. So I'm just going to do this whole example in the negative direction. Going in the negative direction, this will be pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4 in the negative direction, right? So if I want to find out where is negative 9 pi over 4, you just continue going around here. Guys, I probably expect you to be writing this down rather than putting your stuff away, because we still have 5 minutes left in class. So please write down this example, because this is exactly how you're supposed to do your 2 homework problems, which will probably show up on a homework quiz so you can have it. Anyway, so you're going to keep on going around in this direction. Well, 4, 5, 6, 7, 8, 9, right? So you guys think, oh, well, here's my point. And then you guys should know what I told you to memorize was your coordinate point here, square root of 2 over 2, is when for pi over 4. So if I was looking, what is this point down here? It's just a reflection of this point, a reflection over your x-axis. Therefore, my y is going to be negative. All right, so what I want to do is I want to show you how we can do that by using period as an aid. Guys, please. So what I want to do is I want to represent something. If you guys notice, when we went to this angle, we already went around 360 degrees, right? We went around a revolution. That's kind of like redundant, right? We can get to that point a lot quicker if we understand that we're just going around in circles. What you'll notice is angles a lot of times can go around and around and around and around, and then finally end at a point. But we don't care how many times it went around when we need to find our point, do we? We just need to find how far does it go after it's done its revolutions, how far does it go after that. So what we're going to do is we're going to write this as sine, and since it's negative, of negative 2 theta plus t. And we don't really care about this, but what this is this is just factoring, this is just redundancy. It's just, going over revolutions. Well, what is negative 2 pi in terms of my denominator 4? If this was negative, if this is 4 pi over 4, then this becomes 8 pi over 4, right? So what I say is sine of negative 8 pi over 4 plus t. So what is my angle that I have to add to go from negative 8 pi over t plus 4 plus what number gives me negative 9 pi over 4?
1.
Negative 1, right? So I can rewrite this as, or I could say, sine of negative 8 pi over 4 minus pi over 4. Is that the same as that answer?
Yeah.
Yes, right? It's just written a little bit differently. Well, it's written with my revolution of 2 pi factored out. And what we say is, when you can write it as a period, with the period as an aid, we can simply just write negative pi over 4, which is a lot easier. You guys should know that negative pi over 4 is just down that way, right? Instead of like sectioning it all off, going over 360, sine of negative pi over 4 is easily, I just go like this. Boom. Where's that angle? What is that point? Right there. All right. Then remember, the sine is your y value. So sine of negative pi over 4 is equal to the y value, which is negative square root of 2 over 2. Yes, Josh?
Is it kind of like coterminal angles where you can add or subtract 2 pi?
Yeah, it's, well, kind of. What it's just saying is, yes, it is kind of like what it's doing is, you know, coterminal angles is, we said coterminal angles were like multiples of 2 pi, right? So what they're saying is, if you have like two angles that are like coterminal, what we're doing is, by writing it as a period of aide, you're kind of getting rid of all those multiples, right? So you're just focusing on what is actually my least direction, you know, what is the smallest angle to get to my, or what is the smallest, you know, path to get to my angle. So yes, you're kind of like getting rid of that coterminal part of it, which is like the multiples of 2 pi.
Okay.
Anybody have any last questions on that?
Like you assigned it to us